Alright, subpart G, electronically controlled pneumatic brake systems. Oh, October, or ECP. October 16, 2008, FRA issued the final ruling of electronically controlled pneumatic brake systems (ECP) C73 Fed Regulation 61512 through 61557. It is added that subpart G of the Part 232 that the new parts of the rest of the electronically controlled pneumatic brake system of the freight train of the regulation is designed to encourage the safety and implementation of the use of electronic controlled pneumatic brake system technology. It contains specific requirements relating to the design and operability, training, inspection, testing, handling defective equipment periodically, maintenance required related to electronically controlled pneumatic brake systems. The electronically controlled pneumatic brake system radically improved the operation of automatic brake air brake system using electronically transmission signal application, releasing the brake on each of the train while they're still using the force of the brake shoe against the wheel. The electronically controlled brake shoe pneumatic brakes also greatly simplified the braking system electronically. Multiple pneumatic brakes used the conventional brakes, replacing with them with a printed circuit board microprocessor, one electronically equipped with the applicable value application valve, one electrically operated release valve with the feedback of the brake cylinder pressure of the control. Electronic controlled brake pneumatic system technology requires the adding of equipment to locomotive that the car is unique to the operation of the electronic controlled pneumatic brakes. The system requires the brake pipe to supply the compressed air for the locomotive of each of the car reserve train. The similarities between the conventional and the electronically controlled pneumatic brakes and there. Instead of these reduction, increase the brake pipe pressure to convey the application release the signal to each of the train. The electronically controlled brake pipe technology uses the electronical signals resulting in virtually instantaneously application release of the brake on each of the car and entire train. Since the brake pipe pressure has no longer service to the communication with the medium of the end control, electronically controlled pneumatic brake equipped trains, the brake pipe constantly supplied with the charge of compressed air from the locomotive regardless whether the brakes are applied or released. In addition, with electronically controlled pneumatic brakes equipped with trains offer graduated release, whether the particular release command provides partial or proportional brake release. The adopted transmission of the application release signal with the Viva, the two-wire cable-based system. The electronical components are the head end unit, the engineering and electronically controlled pneumatic system interferes with the control of the brake application release. They on current electronic control pneumatic locomotives. This has been incorporated to the WABTEC and the NYAB electronic locomotive systems and display. See Figure 8. Figure 7 shows the New York air brake standalone head unit. This shows the number 8 integrated electronic control pneumatic brakes locomotive display. Alright, the car control identification device, or CCID, of the car control device, CCD, the microprocessor based from the control unit that receives the commands from the locomotive that sends status falls back to the locomotive. The car control device is an electronic device replacing the conventional pneumatic services emergency portions during the electronic braking function of the car control device technology interprets the single part of the head end unit is sending in the warning signals in the locomotive in the event of the component fails to appropriately respond to the brake end of the each car control identification device has a unique electronic address located in the car ID module, which is key for the key to the car's reporting mark number, including the car configuration. WABTEC's car control identification and manifold are separate components within the NYABC car control identification manifold are combined unit. See Figure 12. Alright, Figure 9 is a WABTEC car control identification device. 10 is a WebTex car control identification device. This is a WebTex separate manifold. This is a New York air brake car control device manifold. Locomotive power figure C Figure 13, which converts 74 volt VDCs to 203 volt direct current, 24 volt direct current. Used in car sequencing, used powered by the head end unit in the car control device. The AR standard single power supply will supply the necessary current voltage to at least 1,660 car control devices and an electronic control pneumatic end of the train. The FRA defines the east end of control pneumatic end of the train device in Title 49 CFR 232.5. The end of the train device and control an electronic control brake system physically. The last network noted that the train pneumatically electronically controlled the end of the train line cable operating with the end of the electronically controlled pneumatic brake system, and it transmit a status box end of the train beacon. At least 1 per second contains a mean of the communication of the head end of the train unit train, the brake pipe pressure transducer, battery of the charge off in the train line cable. See Figure 14. Figure 14 is the end of the train, electronic control point of the end of the train. Each car is continued locomotive. The NAY bug type of the Figure 15. Junction box at the rear of the car is equipped with the electronic control pneumatic at the end of the train of the device with a normal pneumatic two-way end of the train device. Figure 15 shows the intercar connectors. One located to provide sufficient vertical clearance, not causing a tripping hazard, not hanging at one end of the free from whenever single equipment is equipped with the train movement, not being positioned to interfere with the use of the safety appliance, not having any of the following conditions: badly shaft or broken insulation, broken plugs, receptacles, terminals, or broken producing strands of wire. Prior to October 16, 2008, the FRA continued granted a waiver part of the documented number of the FRA 2006-26435, therefore allowing the BNSF Railway and North Southfolk Railway to install the electronic control pneumatic brake system pilot trains to demonstrate the safety and efficiency of the technology revenue service. Under the waiver, the trains equipped with the electronic control pneumatic brake system were allowed to travel up to 3,500 miles without undergoing any certain routine brake inspection, more the double distance currently allowed by the federal regulation. Now the final rule has been issued with the waivers not longer in effect. Alright, 232.602. Applicability. Subpart G to all railroads if operated with the rail car and freight train governed by this part, equipped with the electronic control pneumatic brake system, usually and specifically accepted, modified this section. All other requirements contained in this part are applicable to freight car and freight train equipped with the electronic control pneumatic brake system. So the rest of this is in electric control pneumatic part brake system. 232.605 training requirements. Inspection, testing, and maintenance. Paragraph A. Provided with the railroad operates with the freight car, freight train equipped with the electronic pneumatic brake system must adopt and comply with the training qualification designation program with the employees to perform inspection, testing of the maintenance electronic control pneumatic system. The training program required in this section shall meet the requirements of Statute 232.203 A, B, E, and F. The paragraph is also applicable to each of the contractor to perform inspection, testing, maintenance of the freight car, freight of the train equips with the electronic control pneumatic brake system. Operating rules. Paragraph B required the railroad operating freight train of the freight car equipped with the electronic control pneumatic brake system to amend the operating rules governing the safe train handling procedure with the electronic control pneumatic brake system equipment under all railroad conditions, which shall be tailored with the specific equipment and territory of the railroad. Locomotive engineers. Paragraph C. With the railroad operating freight train and freight cars equipped with the electronic control and brake system must incorporate the safe training procedures within electronic control and brake system equipment, specific knowledge and skills, ability criteria entitled 49 CFR Part 240. 232.607, the inspection testing requirement. Internal terminal. Paragraph A, the freight train operating with the electronic control pneumatic brakes should be Class 1 brakes as described in Statute 232.205. The qualified mechanical inspector shall receive the pre-departure freight inspection pursuant to Part 215 of the chapter of the inspector designated in Statute 215.11 of the chapter and part of this origin and initial terminal. Trains en route. Paragraph B provides the except from the unit of the cycle with the train operating in the electronic control pneumatic brake mode shall not operate within distance exceeding the destination of 3,500 miles, whichever is unless another inspection meeting the requirements of the paragraph A of this section is performed in the train. Unit cycle of the train operating with electronic control pneumatic brakes mode should receive inspection and required in paragraph A of the section at least 3,500 miles. A freight train operating electronic control pneumatic brake mode should receive a Class 1 brake test as described in Statute 232.305. The qualified person at location where the train is off air at the period of more than 24 hours or 80 hours. The train remains inaccessible for the railroad to extend off the air facility. Cars added en route. Each car equipped with the electronic control new brake system that is added to the train operating in electronic control pneumatic brakes mode should receive a Class 1 brake test as described in Statute 232-205 by a qualified person unless all the following are met. The car has received a Class 1 brake test by the qualified mechanical inspector within the last 3,500 miles. Information identified with the Statute 232-205E relating to the performance previously received in Class 1 brake test provided with the train crew. The car has not been off air for more than 24 hours. The visual inspection of the car brake system conducted to ensure the brake equipment is intact properly and secure. This may accomplish the part of the inspection under the Statute 215.13 with the chapter. It may be conducted while the car is off air. Each of the car and each of the solid block cannot be equipped with the electronic control pneumatic brake system. This is added to the train operating in electronic control pneumatic brake mode. Shall receive the visual inspection to ensure that properly placed with the train unsafe to operate should move the tag in accordance with the provision contained in the Statute 232.15. Class 3 brake test of freight train operating with the electronic control pneumatic brake system mode shall receive a Class 3 brake test as described in Statute 232-211 B, C, and D. With the location configuration of the train is changed and included when the locomotive of the crew is changed when the car and the solid block is added to the train, where car or solid block of cars are removed from the train whenever the continuity of the brake pipe or electrical connections is broken and interpreted with the train consisting of other remaining unchanged. Initialization paragraph E states that the freight train should initialize the following occurs: Class 1 brake test, Class 3 brake test, and when the electronic control pneumatic brake system is powered on. The initial process shall maintain being in accordance with the Association of American Standards, the S4200, perform in subsequential order of the vehicle of the freight cars of the train. Once the electronic control pneumatic brake system is initialized, the train crew must ensure that the total number of the cars indicated by the electronic control pneumatic brake system is the same as the total number of the cars indicated by the train consists. Modification of existing brake system and in lieu of the specific brake pipe reduction, increasing the required in subpart C, the part of electronical signals provided with the equivalent application release of the brake shall be used in conducting any required inspection and testing of the freight car of the freight train equipped with the electronic control pneumatic brake system operating on the electronic control pneumatic. In lieu of the specific minimum requirements traveling ranges of the Statute 232-205C5, the position travel freight cars equipped with the electronic control pneumatic brakes will be within traveling limits. Stenciled marked or car badge consistent with the manufacturer recommendation limits is stenciled and marked. Exemption of freight of the freight car shall be exemption with the requirements contained in the Statute 232-205A and B and the 232-207, 232-209, 232-211A when it's equipped with the electronic control pneumatic brake system operating the electronic control pneumatic brakes mode. 232-609 handling device equipment electronic control pneumatic brake. Paragraph A requires 95% of the car to train electronic control pneumatic brake mode shall be effective for operating brakes prior to the departure of the train initial terminal location of the Class 1 brake test as required and performed the entire train by a qualified mechanical inspector pursuant to Statute 232-607. Paragraph B provides the freight car equipped with the electronic control pneumatic brake system to have arrived in effective on and operative brakes at the location initial terminal at the location Class 1 brake tests are required in Statute 232-607B. That shall not be ordered in location and effective in an operative brake train operating within an electronic control pneumatic brake mode unless the car does not have the ability to conduct the necessary repairs to the car. The location does not have the ability to conduct the necessary repairs to the cars as hauled, but only the purpose of repair the nearest affordable location for the nearest repair and be performed and consistent with the guidance contained in the Statute 232-15F. The car does not place in loading and unloading will move unless the loading is unnecessary for the safe repair of the car. The car is properly tagged in accordance with Statute 232-15B, pursuant to the paragraph C of the freight car equipped with the conventional pneumatic brakes are shown not within the freight of operating with the electronic control pneumatic brakes on the road, and unless it was otherwise effective with the operative if the forward conventional pneumatic brakes equipped with an or could have been moved to the location to effective condition under the provision Statute 232-15 with the tag in accordance with the 215B. A freight train operating in electronic control pneumatic brake mode shall not move in less than 85% of the cars in the train operative effective. However, after experiencing the penalty stopping that less than 85% operative effective brakes freight operating in the electronic control pneumatic brake mode be moved in the following are met. A train is visually inspected. Appropriate measures be taken to ensure that the train is safely operated with the location when necessary repairs to be changed and consistent may be made. Qualified person determines the safe of the move of the train, and the train is moved within controlling pneumatic brake switch mode to the nearest forward location where the necessary repairs and changes can be made. Under the paragraph E, the freight car locomotive equipped with the electronic control pneumatic brake system that was found inoperative and ineffective with the fitness of the brake for the first time. The period performance of the Class 1 brake test while en route may use the handhold without civil liabilities under this part of the destination not exceed 3,500, provided with the availability of Statute 232-609 are met. Defective car and locomotive is hauled with the train operating in electronic control pneumatic brakes mode. Freight equipped with the electronic control pneumatic brake system that is part of the train operating control electronic control pneumatic brakes is found defective non-brake safety appliance may be applied, may be used or hauled out with a civil penalty without a civil penalty. Part of the newest forward location where the nearest repairs can be performed consistent with the guidance contained in the statute 232-15F. Train operating with conventional pneumatic brakes should operate with the freight cars equipped with the standalone equipment control pneumatic brake system unless the train is the least minimum percentage of the operating brakes required with the statute of 232-609H when an initial terminal is 232-609D when en route. The standalone electronic control pneumatic brake equipments are moved for purpose of delivery railroad receiving the equipment and to the location placement of the training operating and electronic control pneumatic brake mode moved to the repair of the nearest available location where necessary repairs can be made with accordance with statute 32-15A and 5 A and F A 7 and F. Tagged in accordance with 232-15B is placed in the train in accordance with 232-15E. Paragraph H allows the train accordingly operated with conventional pneumatic brakes to depart. Initial terminal freight cars and equipped with the standalone electronic control pneumatic brake system provided and the following are met. 1. The train has at least 100% of operative of the brakes that are all equipped with conventional pneumatic brakes. The train has at least 90% effective operative brakes, including the freight trains equipped with the standalone electronic control pneumatic brake system. The requirements are contained in paragraph 232-609G are met. Tagging defective equipment after a freight car equipped with the electronic control pneumatic brake system is found with ineffective and inoperative brakes will consider electronically tagged under statute 232-15B1 and B5, and the cars used and unhauled in train operating in the electronic control pneumatic brake mode. The electronic control pneumatic brake system meets the following. The electronic control pneumatic brake system is able to display information with the cab or lead of the locomotive regarding locomotive location and identification of the car with the defective brakes. The information stored and downloaded and secured and accessible with the FRA operating with the inspection term personnel. 3. An electronic written record of the stored and downloaded information retained and maintained in accordance with the statute 232-15B3. 232-611 periodic maintenance. Paragraph A requires additional maintenance requirements contained in statute 232-303A, B and D through freight car equipped with the electronic control pneumatic brakes shall be inspected before and being released from the shop and repair track to ensure the proper safe condition of the following. 1. The electronic control pneumatic brake system wiring brackets, electronic control pneumatic brake system electronic connections, car-mounted electronic control pneumatic brake system components exemption. A freight car equipped with the standalone electronic control pneumatic brake system is accepted from the signal car testing requirements contained in statute 232-305B5 and B2 and F. Alright, 232-613, end of the train devices. An electronic control pneumatic end of the train device shall be minimum service and file noted with the node of the electronic control and brake circuit provided with the electronic terminal circuit monitoring confirm the report of the train brake pipe, the train line cable, continuity, cable voltage, brake pipe pressure, the status of the end control pneumatic end of the train device, battery charge. Railroad shall not move the freight train equipped with an electronic control pneumatic brake system unless the train is equipped with the functional electronic control end of the train device pursuant to the paragraph A of this section. The railroad complies with the paragraph B of this section. Then the control pneumatic end of the train device must be properly connected to the network and the train line cable at the end of the train. Exemptions of freight train operating engine and electronic control pneumatic brake mode accepted at the end of the train. The equipment contained with subpart E, the part provided with the equipment of the electronic control pneumatic and of the train device complying with this section. Note that the motive power and equipment technical number 2 new source defective codes, electronic control pneumatic brake equipment inspection, the new inspection report requirements on the out shaft locomotive of the car. Inspector should review the technical bulletin related to the electronic control pneumatic inspection activity, out shaft inspection activity. Guidance for Appendix B of Part 232 or Part 232 prior to May 31st, 2001, clarified effective April 2nd, 10th, 2002. Alright, motor power and equipment 9859 train brake inspection. When performing initial terminal train brake air brake testing under Title 49 232 15 12 C through J, inspection train brakes should be made to determine the brakes applied with each of the car. The parade and travel brake rigging does not bind or follow that all the brake equipment properly secured. The 1,000 mile train brake test under the Title 49 CFR 232-12B also requires that the brake applies on each of the car responsive 20-pound surface brake pipe reduction. If the brake rigging properly secured and does not bind or follow the TMX truck mounted brakes of the Wabtec indicator at each of the end of the section. Although the regulation does not specify the physical action necessary to conduct the proper inspection, railroad may fully fulfill the inspection requirements only if the inspector positions themselves in the way that permits the required observation noted above made. Obviously, the railroad inspector can visually inspect only what he or she sees in the position to see it. As the vast majority of all freight cars are equipped with the air brake equipment, the brake cylinders and brake indicators and brake rigging that cannot be observed when the inspection are made only on one side of the car. Properly into initial terminal 1,000 mile train air brake inspection shall be performed. Inspection on both sides of every car on the train. The following inspection practices would be safety regulations. After the car is assembled, the qualified individual will connect the air hoses on one side, perform the inspection of the brake equipment to ensure the brake components are properly secured. The brake rigging is not binding of the following. The brake shoes are not in proper condition. The brake system is then charged with the air pressure of the rear of the train, checked to ensure the required level. At the point of the brake is supplied with the qualified individual to perform the brake inspection other than the second side of the train to ensure the brake components are rigging and the properly secured, but do not bind with the following. The brake shoes are against the wheel. During the inspection, individuals will also check the proper position crossing over the cars inside one of the position cannot be observed from side 2. At the conclusion of the inspection, the brakes then release. The individual then walks off the release of the brakes, observe the brake release, and the train rolls back at low speed. If the roll inspection of the brake release is performed, the individual performing the inspection must have same method communication with the train crew. The resulting inspection, FRA believes the inspection of the brake components, rigging, and shoes must be conducted by both virtually every car sometime during the inspection process. Moving utility vehicle may be performed in these inspections. However, the inspection must be made in a speed and manner will permit the qualified person to clearly observe and determine the condition of the air brake equipment if the piston travel is within the limits.